Okay, so this is a question from section 2.4 of the book about continuity, and it's asking us to find the values of this constant c, which make the function continuous. So if we look at this, this is a piecewise defined function. For x less than 5, the function is x squared minus c. And for x greater than or equal to 5, we have 4x plus 2c. So when x is less than 5, this looks like a parabola, and when x is greater than or equal to 5, this function looks like a line. Both of those parts are continuous. First of all, because we know what the graphs of parabolas and lines look like, but also you could say that those are polynomials. So when x is less than 5 or when x is greater than 5, we have polynomials and things are continuous. The only point that we really have to worry about is this point 5. We want to know whether the limit from the left and the limit from the right are equal. So in other words, whether the two parts of the graph match up. So just write that down. So we're just checking at x equals 5. So we want to think about the limit as x goes to 5 from the left of f of x, and also the limit from the right. But let's start with the limit from the left. Okay, so if x is a little bit less than 5 and it's approaching 5, then we are on the part of the graph that looks like the parabola x squared minus c. Now, so this is the limit as x goes to 5 from the left of x squared minus c. Okay, but like I said, parabolas are continuous, so this limit will just be 25 minus c. We could have just plugged in because that part of the graph is continuous. And now if we take the limit as x goes to 5 from the right, now if we're a little bit bigger than 5, if x is a little bit bigger than 5, we're on the part of the graph that looks like the line 4x plus 2c. So uh, 4x plus 2c. And again, this is continuous, this line. So when we take the limit, we can just plug in that point at the end, and we'll get 20 plus 2c. Right, and so for our function to be continuous at 5, that means that the left limit and the right limit have to agree, and they have to agree with the value of the function. So we want 25 minus c, which is the limit from the left, to be equal to the limit from the right. And this limit from the right is also equal to f of 5. So we want the limit from the left to be equal to the limit from the right, and then that will be the limit as f goes to 5. And we also want that to be equal to the value of the function. We get that for free since the limit from the right is equal to the value of the function. So we just need to solve for c here, and we get that 5 is equal to 3c, so c is equal to 5/3.